As we begin our solutions unit, we're going to be looking at molarity, which is a solution concentration often used in chemistry. Now, molarity is a unit of moles per liter. It's the amount of moles of your solute, the solid stuff, dissolved into the aqueous solution. Now, it really doesn't have to be solid, but for these examples here that I'm going to do, they are solids. So we're just going to do a couple calculations, and it should help you make sense out of this. Determine the molarity of a solution that has 1.5 moles of calcium sulfate and a total volume of 500 milliliters. So the way we do that is we say I've got 1.4 moles of calcium sulfate. So 1.4 moles. And notice I'm writing my label, CaSO4. And I'm just going to times that by 1 over, now I have to convert my milliliters into liters. That means I got to move my decimal 3 to the left because I'm dividing by 1,000. So divide that by 0.500. Since I have a decimal point, those zeros are significant. And I have the liters to mark that. So then we'll have moles divided by liters, which then equals 2.8. And my capital M stands for molarity, moles per liter. So that's all I have to write. And then CaSO4. And that's its concentration. Moles divided by the total volume of liquid that everything's dissolved in. Now, next one, what if I've been given grams? Well, you guys know grams need to go to moles using the molar mass of the compound. Now, the molar mass of calcium chloride is 110.9. Okay, so we'll get started with that. Determine this molarity. So now I'm just going to have one extra step to this. I have 12.4 grams of calcium chloride. I'm going to times that by 1 mole of calcium chloride over that molar mass of 110.9 grams of calcium chloride, because that's simply moles to grams into moles. And then I'm going to multiply that by my liters, 1 over my liters. 1 divided by, now remember I have to divide this by 1,000 again, move it 3 decimal places to the left, and that's 0.450 liters equals, and that gives me a concentration then of 0.248 moles per liter. Now remember, I'm just going to put a capital M because that's what molarity stands for, a capital M, CaCl2, just like that. So again, nothing too difficult to calculate. Just if you're in grams already, just get into moles and then divide it by your liters, and that's its concentration. Now, of course, the more grams you have, the more moles you have, the more concentrated it is. Now, what if you're trying to make a solution? So let's say I want to make 350 milliliters of a 0.50 molar sodium chloride solution. So then I'll start with my milliliters, converting it to liters. So 0.350 liters. I'm then going to multiply that by my concentration, 0.50 moles of NaCl per 1 liter. And again, that capital M stands for moles per liter. Now I've got moles, because like I can cross off my liters. I've got moles, and I just need to go from moles to grams, again, which we've done a lot this year. So I'm going to multiply that by 58.5 grams of NaCl over 1 mole of NaCl. Okay, and then I'll just be multiplying all those together then, and that gives me 10.2 grams of NaCl. Okay, so that's our calculation to get us into grams of NaCl. Now, what if we want to talk about the ions that are present? So I've got 2 different solutions here. 0.350 molarity aluminum chloride and 0.125 molarity tin phosphate. We want to know what the molarity of the ions are. And by the way, the capital M, you can abbreviate that in a different way. You can use the word molar. So like I say, this is 0.35 molar aluminum chloride, 0.125 molar tin phosphate. So I'm going to get the ions on this. The charge of aluminum, of course, is +3 from your periodic table. This is -1. Phosphate, of course, is -3. And the tin for this must be +4 to make that +12 and -12. And to get our concentrations of ions, then, it's not too hard. I'm going to take 0.350, and that's moles of aluminum chloride per 1 liter. I'll times that by 1 mole of aluminum +3 per 1 mole of aluminum chloride. Why? Because there's 1 aluminum for every one of those. So the molarity of the aluminum ions from this solution is the same, 0.350 molar aluminum +3. Now, when I want to do the chloride, okay, the first step stays the same. I'm just going to go down here. I'm kind of cheating you just a little bit. Okay, so instead of doing this, I'm going to say times. So there's 3 moles of chloride -1 per 1 mole of aluminum chloride. And that means we have 3 times the amount of a chloride ion. So that'd be 1.05 molar Cl-1 ions. So we get 3 times the amount of chloride for every 1 aluminum, because that's what the formula says. Okay, now let's do the tin phosphate. That's the tin 4 phosphate. So I'm going to start with the 0.125 moles of tin phosphate. And again, that's per 1 liter. I see that there's 3 tins for every 1 tin phosphate. So I'm going to say times 3 moles of tin +4 per 1 mole of tin phosphate. Okay, and that's going to equal, again, we're just going to multiply that, okay, through by 3 there, and we're going to get 0.375 molar tin +4. Now likewise, I'm going to cheat again. I'm going to do this other one down here. We're going to say times. Now I'm getting 4 moles of phosphate, so 4 moles of PO4 -3 per 1 mole of tin phosphate. Okay, and that equals 0.500 moles molar phosphate ions. So we can get the concentration of the ions in each solution. You're going to see that that's an important thing to be able to do when dealing with solutions and molarity and concentrations. Okay, that's it for now. We'll do another video later.